Hey everyone, thank you. I'm excited to be here, and I'm going to be talking about how do we balance the cloud, network, and edge to basically deliver the best experiences for remote work and play, especially because we have seen a lot of thoughts on what remote work and play means from an experiences perspective. And we use the terms cloud, devices, client on day-to-day basis, but there's some very fundamental part of that particular experiences which is taken for granted. That is basically how are these particular devices getting the experiences delivered to them through network and edge. So how are the experiences being delivered from cloud to devices through network and and the Internet of Things like an edge? And what are some of the key trends we are seeing, challenges we are seeing into this particular part of the network, so that we can drive to some of the innovations to deliver the remote work and play future, right? So in this particular talk, I'm going to talk about what are some of the key trends, like I said, challenges, and some of the innovations that we are actively working on as an industry to basically build this infrastructure to support like a seamless remote work and play paradigm. On the right side, the visual that we have, it's what we like to call donut, where you see the data center at the center of the donut, and around it, at the far beyond the donut is actually the devices which are seeing all the experiences, services and stuff. What is inside it is basically this distributed infrastructure of compute, etc., which is basically the network. And then we have the network, and beyond the network, like an edge, which is fundamental to basically delivering. And this is the backbone of the packets and the data, the experiences going back and forth across the data center and the devices. This part of the picture becomes extremely important, especially as we look at 5G and beyond 5G, where the number of devices that we see across this particular donut is exploding exponentially. And this is basically stressing tremendously our infrastructure all the way from edge, network, and cloud and back. This exponential growth comes with the fact that we have data exploding, sensors exploding across, and every device that can basically connect and talk is expected to be computing or like a smart device. So in the next slide, I'll actually talk about some of the key trends that basically drive this particular remote work and play challenges, especially from my perspective of network and edge, and what are some of the key complexities as well as innovations that it that it expects us to drive. So one of the key things I should mention is the reason why network and edge becomes important than just becoming the backbone is, as the number of devices explode across the edge, we cannot expect all the processing to be happened in a centralized fashion at, say, data center or cloud. We need to have the raw data being pre-processed at some of these intermediate points, so that we are actually culminating the smartness at the cloud, and we're actually processing pre-processing some of this raw data across the path, so that we have like a distributed computing infrastructure all the way from device to cloud. So network and edge are not just the backbone; they should be looked at as computing devices or computing nodes across the path, where they have their own level of smartness and compute like IO, etc., for them to basically feed this particular spectrum of remote work and play that go back and forth, right? So let me move to the next slide. So some of the key trends that we basically talk about is we have billions of devices basically becoming connected across the world that drive extreme need for network capacity to scale with them. On the far left, we have some ultra reliable, low latency, ultra mission critical experiences that we actually want to unleash with the coming of 5G and 6G. Industrial robotics, surgeries, autonomous cars, emergency services. These need ultra low latency, SLAs that are extremely strict, And again, they're a form of remote work and play in the sense that they need to traverse across the device to the central node of processing and back. So that particular class of application stress are, like I said, latency, reliability, communications across the board. And then we have the massive connectivity that we are seeing across the globe. Machine-generated data is exploding. The communication that is required to basically coordinate and extract some smartness from these machine-generated data, especially from something like smart cities, smart factories, smart retail, becomes extremely important. And AI is becoming more fundamental across the board and not just in one or certain parts of the network. Network for efficiency, network for smartness, network for meta information, you name, I'm sorry, AI for smartness, you basically name it. And then we have the multi-user, multiplayer sort of like a world where we speak about metaverse. We have enhanced broadband connectivity expectations where we can deliver high capacity, high throughput, multiplayer, efficient experiences, starting with like a simple thing like a video conference, gaming, video streaming, education especially, and of course, fading into the world of metaverse at some point. So every single one of these classes of experiences basically stresses all the way from edge to network to cloud and back. This slide basically talks about my view of things on the excitement in this space and why this is not like a one-dimensional or like a two-dimensional problem. The complexity and challenges that we have to look at to basically get to a level of, as an example, 5G and 6G spec talk about having global connectivity, 90% and above. What does that mean? We need to have every device that actually, that is in the space, on the land, in the water, no matter what, is a connected device, basically capable of computing and actually transferring things around. That's one of the key trends that we expect to happen in 5G and beyond as an era. And then we have the blow up of private wireless networks at scale. And then we have high performance workloads and actually use cases that we just saw. What this means, just from four vectors, if you will, connection density perspective, moving from 3G, 4G to 5G and 6G, we're looking at the density or the devices per actually kilometer square going 100x, 10 to the power of 6 to 8 and more. And then we have data throughput at an edge driven by the sensors and the compute devices going from what we called petabytes to zettabytes and beyond, 10 to the power of 12 to beyond, right? Latencies, experiences like we actually spoke about, medical experience, military, SLAs are extremely strict, extremely strict. We are looking at latencies being more efficient by a factor of at least 10x. And then we have reliability, which is taking us from where we are with 5 nines to 7 nines. All of this basically drives the need for innovation across multiple facets. 5G and wireless innovations, we've been following some of the specs and standards there, exploding again. Efficient network densification becomes important. And networks can't be static anymore. They need to be dynamic. They need to be smart. They need to be efficient, autonomous, so that we don't think of network as a static anymore. It is like a movable piece of puzzle now. And within the networks, the nodes itself, the memory, the connectivity between the devices, inside the devices, across the devices, scale up and scale out, those become important. SLAs, like I mentioned, ultra low latency experiences. Security is foundational and fundamental. Moving data across so many different personas of compute requires us to think of security as a foundational pillar across the board. And that's no simple feat, especially when you look at security as not just like a silicon feature, but you have to look at security from a software, silicon, and as a service level expectation feature now. Resilience, redundancy, recovery, critical ones for mission critical applications. And one of the key things is unified software, where it applies. Imagine an experience, gaming or VDI, etc., that is actually flowing across this particular different parts of the network and back. And you might not necessarily have the same compute element or architecture, which is actually which is taking these experiences back and forth. You can't have the cost of software multiplying across every different hub because that is extra cost. So how do we build like a unified open software ecosystem that can leverage and actually deliver to some of these seamless experiences? High efficiency. We don't want to do everything of these by multiplying the amount of power or the watts that we want. Every one of us is actually, we know that we have to be responsible, sustainable. So how do we achieve this in a carbon neutral or like a very sustainable fashion across the board is supremely important. So performance per watt at a very different level, exponential level of performance, but power starts to become more of a expectation of being the same. Sustainability and high efficiency across the board. So these are the multifaceted problems that you have to grapple with when you're looking at these particular services going from edge to network to cloud and back. Especially, like I said, with the densification of networks and devices explosion at network and edge, the problem becomes super exciting because you basically have to look at all these different facets to deliver these experiences and meet their like an SLAs or latency expectations across the board. So that basically drives us to some of the key innovations to basically achieve the remote work and play future. I think some of the fellow speakers also spoke about this, right? End-to-end system perspective. We are not in the race to basically build the best of a CPU, best of a GPU, best of bag of parts anymore. We need to be thinking about a seamless in the form of software, be it composable so that you can scale up and down, and scalable solutions which can also scale like out to basically deliver these experiences or usages, if you will, across the board. So again, not a bag of parts, no one solution fits all, no best CPU, no best GPU or like a DPU or like an IPU anymore. It's like what makes the best solution or to basically deliver the experience and look at it at a holistic view. Open software so that we can continue to drive innovations that can be abstracted across multiple layers. Working through standards bodies to basically drive these particular innovations becomes extremely important so that it's a collaborative like an effort. It is not one company, one vendor sort of a story. It takes collective innovations to basically bring these experiences to fore. So in this slide, I named some of them which I'm intrigued about, and I look at each of the points on his graph basically talk about some expectations on why these are the most, some of the most important pillars that are needed to be innovated on for the remote work and play. And innovations in each of these drives basically a significant leap forward for us as an industry to innovate them. For edge, wireless, Wi-Fi 6, 5G, critical. And then we have the machine learning and deep learning at these device edges. Software that becomes important. So the interaction between devices and sensors, which is actually one example being V2X or etc. Those are some of the key innovations that are actually driving the edge part of the program. For example, wireless, like I mentioned. How do we basically deliver like a Wi-Fi 6 sort of a standard where we can have like a private wireless across the board? And then network, virtualization of RAN, radio access network. 5G core infrastructure scalability, super important. And AI again in network, efficient network, where we can optimize the efficiencies by, say, something like a cell capacity planning. How do we drive down power consumption by cycling through some power states into like within like processor? Small things, but every innovation counts to basically build to like a sustainable future. In the compute, like I said, it's no more building the best CPU or GPU anymore, or even and like a DPU or like an IPU, right? It's architecture diversity. We need to understand what is the right architectural construct to basically deliver some of these, services. In the next slide, we, talk about scalar, vector, and things like that. And the compute portfolio becomes super important. Again, going back to the solution approach, memory and IO, very key innovation pillars. For example, in IO, especially all the way from within the die to package actually innovations, ultra-path interconnect, Ethernet, everything that basically takes us from within the node to across different nodes and systems, key innovation vector. Security, trusted execution, like secure, like a non-clave execution. Confidential computing, especially as we see machine learning and deep learning becoming more fundamental across the board. Having a paradigm where the model security, data security is foundational is important, right? End-to-end security is important because the experiences are flowing across the entire network. So how do you make sure that each part of the network, like edge, network, and data center, together, when you look at them, they're actually secure channel, like or pipe established across the board. That's super important. And sustainability is very fundamental. No matter what we do across the board, we need to make sure that we are being, we are not increasing the power. We have our eyes set on a very sustainable future. So these are some of the key vectors that excite me, and I'm actually working on with some of our industry partners as well. And in the next slide, I basically give a call out to some of the key technologies Intel has done in the last couple of years. And this is by no means the extent of what we can do. This is just a few of the actually innovations from us. But we need the industry as a whole to basically work on this together. It's a grand challenge. And I think innovating together, partnering along these particular vectors to get to the remote work and play future is supremely important. Applied innovations become supremely important. This is, again, not building the best CPU in the world, but how do we build the applied product or the platform that can deliver the experiences and actually products to the devices, right? So I talk about some of the key innovations that we are doing from actually Intel side, and a lot of these particular innovations are driven by partners on the call as well. We have edge innovations we have the Intel Wi-Fi 6E products, Intel time synchronization capability. On the network side, we have the ORAN efforts that we continue to drive, and our continued participation in the 3GPP. On the compute side, just like my fellow speakers, every one of us is investing into looking at scalar, vector, matrix, spatial, different sort of compute, patterns and architectures to basically deliver the compute portfolio, right? And on the memory side, UPI, UCIe, all of these actually innovations basically help us drive some of the scale up and the scale out architectures. On the security side, the cryptography, the confidential computing, trusted domain of extensions, especially as you look at, we have portfolios now. We're not looking at computing everything within the same compute node anymore. We need modularity. We need the flexibility. So how do you make the entire system secure? So it's not just about making a CPU secure or like a GPU secure. It's like together, how are they basically delivering a secure system to deliver secure experiences? These are some of the most exciting things that we are working on. And as the industry, partners on the call as well, we're actually working on. So that's pretty much what I wanted to, cover, where when we look at remote work and play future in the 5G and beyond place we are in, network and edge play a very crucial fundamental part for us to deliver these particular services, not just from a backbone perspective, but actually becoming intelligent compute nodes that enable us to pre-process and actually process as much information and smartness at these locations, and then progressively go to the data center and cloud to build out these experiences across the board. So with that, Nick, Neil, hopefully I'm within time.
Yeah, you're good. Thank you. That was tremendous. We were one of the big challenges we had when lining up the speakers was we needed someone with a strong networking experience as well, and it was someone who had a full view of the ecosystem. And I'm really grateful that you were able to share with us today.